Powerful people make places powerful.
Types of vectors. So what is the type of vectors we have? Is equal vector. First we have a equal vector. What is equal vector? Vector with equal magnitude, and direction is called as a equal vector. Okay, the vectors with equal magnitude and direction is called as a equal vector. For example, let's see one example, then it will be more clear. Okay, suppose this is my one vector like this, and this is my another vector like this. Okay, this vector is suppose vector A, and this vector is suppose vector B, and the length of both the vectors, suppose this length is L1 and suppose this length is L2. So you can see here my L1 is equal to L2 and the direction is also same, and direction is also same. So it is called as a what? It is a equal vector. Clear? Next we have parallel vector. Okay, what is parallel vector? The vector which has same direction. So the vector which has same direction is called as a parallel vector. Simple. Okay, for example, this is my vector A and this is my vector, another vector. Okay, this is my vector A and this is my vector B. Okay, as you can see the length is not same, I can clearly see, but the directions are same, direction is same. So vector A is parallel to vector B, or vector A you can write it as lambda times of vector B. This is another way of writing the parallel vector in a mathematics. In mathematics we will write the two parallel vectors. Vector A is equal to lambda times of vector B. Clear? Any third number? I think so. Yeah, it is anti-parallel vectors. Now what is anti-parallel vectors? Let us see what do you mean by anti-parallel vectors, sir. The parallel which has a opposite direction, means they are opposite of each other in the direction. Okay, so the vectors which has opposite direction. Okay, opposite direction. Sorry. Which has opposite directions. Okay, means their direction will be opposite. Like, let's take one example, then it will be clear. Suppose this is my one vector, okay, and this is my another vector. So you can see clearly they have a opposite direction. Okay, one direction is on downward and another one direction is upward. So that is called as a anti-parallel vector. So suppose this is my vector A, okay, and this is my vector B. So I can say my vector A is equal to some lambda minus times of lambda into vector B, but there is a no such type of relation. So you don't write, just these two are anti-parallel vectors. Clear? Because they are opposite in direction. Clear? And fourth is co-initial vector. Co-initial vectors. What is co-initial vectors? What is co-initial vectors? Can anyone tell me what do you mean by co-initial vector? Means simply it is clear from the line only, it's only that is a vector which has a same initial point. Okay, okay, the vectors which has same initial points is called as a co-initial vectors. So the vectors which has a same initial point is called as a co-initial vector. Let us see one example, so it will be more clear. Let's see. Suppose this is my one vector, this is my another vector. So you can see clearly it has a same initial point. Okay, and this is my vector A and this is my vector B. So this is called as a my co-initial vector. Clear? Till okay, how to find the magnitude of the vectors. Okay, how to calculate the magnitude of the vectors. So before going to this, we have to understand lot of things, then we will come to the magnitude of the vectors. Okay, the first thing we have to understand is something called as a unit vector. Okay. First thing we have to understand something called as a unit vector. First thing we have to understand what is unit vector. Okay, what is unit vector? Let us see. The vector which has unity magnitude. What do you mean by unity magnitude? Can anyone tell me? Means what do you mean by unity magnitude? Means its magnitude value is 1. What is mean? What is the mean of this? The meaning is simple, that is magnitude of the vector. Suppose the vector is A is equal to 1. That is the simple meaning. Okay, how it is denoted? It is denoted by A cap, that is equal to A vector divided by magnitude of A vector. That is called as my unit vector. Okay, we need unit vector to point the direction. Because whenever we need to point the direction, we use unit vector. That is sure. Okay, that is sure. Whenever we need to point the direction, then we use a unit vector. Clear? Whenever we want to point the direction, then we use a unit vector. Example, let us understand with the example, then it will be more clear. Suppose Ram is moving with 2 meter per second. Ram is moving with 2 meter per second. in positive direction. In positive x direction. We can write this, I can write this thing in different manner also. Like Ram velocity is 2 I cap meter per second. Means this big statement is reduced to this smaller statement. What is the two information we are getting? 2 meter per second, this is donating the 2 meter per second, and I is there. What is that I is telling that it is in the positive x direction. So that is a use of that is a power of a unit vector. We can reduce this big statement into a single line. So we have to now understand I, j and k. What is I, what is j, what is k? Let us see. What is I, what is j, what is k? See, I, then we have j, then we have k cap. I cap, j cap, k cap. What is I? It is the unit, sorry, it is a unit vector in positive x direction. It is a unit vector in positive x direction. Clear? It is a unit vector in positive x direction. So for minus x direction, what will be the unit vector? Can anyone tell? Obviously minus I. For positive x direction it is plus I. So for negative x direction it will be minus I. Similarly, what is j cap? It is a unit vector in plus y direction. It is a unit vector in plus y direction, and this value will be minus j cap. It is unit vector in plus z direction. That is minus z is equal to minus k cap. Clear? So if you draw like this, okay, if you draw like this, if I draw a diagram, I will explain you in better manner. Let us see. Suppose this is my x axis, this is my y axis, and this will be my z axis. Okay, these are the three axes are there. We have x, y and z, correct? Okay, so this is my I, positive x axis. This is my okay, and this will be my origin. Clear? So this is how we represent the unit vector, and this is how we do the representation of a unit vector.